We can go ahead here to the next piece. So this is really fun. Fun for me, I should say. This is this is a large part of what I do. For those that maybe aren't familiar, this is it's a little bit blurry on here on the resolution function, but as we go through the slides, it'll make a pretty clear indication of what's happening here. This is a data log from a engine ECU. For those that might not be familiar with that at that point, basically these are all a bunch of different channels that we're logging that are either telling us what this engine is doing or what we're telling that engine to do via the engine's computer that's running it. What we're looking at here is a single gear pull on an engine, and down here there's a bar graph down here, and this is going to use, I believe, you on the E0 function, that the low ethanol but high octane function deal. This is registering 1.17% ethanol content because we have sensors that can measure that on the fuel system. And 1.17 could truthfully be trace blends of things, maybe some left over in the system or whatnot, but we can effectively look at this as about it could be some moisture buildup in the system. It's basically your E0 gasoline on this. What we see on this yellow line right here, this is what we call a knock threshold on the engine ECU. So we determine this by dyno testing this engine, listening to knock sensors. Everybody in here know what knock sensors are? If nobody does, that's fine. You can be happy to explain it. We can listen to the engine, hone in on certain frequencies, and determine. We will actually forcibly make the engine go into a knock state at different engine RPMs. And so we can determine and say, this is a bad line. Basically, don't go beyond this or there's a real good chance you're going to blow it up. So that's the simple way to look at that. What's really important, there's going to be this next slide. This is our low ethanol content. Then we're going to do this same engine running conditions, so we're giving a true apples to apples comparison here. If you could see it clearly enough, unfortunately you can't on here, but you'll have to take my word for it. Air intake temperature is almost a direct layover. The actual data point we're looking at here, our blue line is the cursor. That is, I believe it's within 50 RPM of the two slides that we're going to have here. Engine oil temperature, all these things have to be very, very similar for this to be a legitimate test. Moving to the next slide here. Now our ethanol content is on this same engine at 72% ethanol content. Quite a bit of ethanol content at that point, but still below what you can get at a normal gas pump, even on E85 stations. This is the same established knock threshold on this engine, and you can see this frequency band of the cylinder counts of the knock sensor data. Air temp is the same, coolant temp is the same, lambda trace on the engine. Ignition timing, so common function, trying to make more power. People try to find peak timing that you can get away with before you go into knock. This is set at the same static timing level, so we can see what is a real A to B difference here. Going to the next slide, now we'll just put those representative up here so you can kind of see this entire frequency band has been lowered across here compared to what we're seeing up here on our E0 function. It's a relatively rudimentary test. However, this gives a very, very good visual representation of that safety window, that reliability window, while being able to make more power that we're able to achieve by incorporating ethanol into our fuels.